Hello friends. Welcome to T Academy. Let's start today's session with a beautiful quote by Sir APJ Abdul Kalam. The quote says that you cannot change your future, but you can change your habits, and surely your habits will change your future. That means, in this quote, the Sir is saying about habits. Okay, so your habits is going to decide your future. So change your habits so that you can change your future here. So with this quote, we'll start our Tneb Instrumentation Engineering last session of this paper. In this paper, I'm majorly focusing on the control system questions, and also I will read out the other questions along with the answers here. So without wasting your time, let's start the session here. The first question is, bellows expansion is done usually against a spring. The spring is provided to. The options are increase sensitivity, increase operating range, increase linearity, decrease hysteresis effect. So answer is, it is increase linearity. Next question here. In FIR filter design using windows, trade-off exists between. The answer is minimum width of main lobe and minimum peak amplitude of the side lobe. Okay. Next question. It's a 106 question. They given equal marks. That is, the question is itself wrong here. So we'll move to the next question here. Question number 110. The layer of ISO OSI protocol stack are. They are 7. Next question here. The D by P cell is used to measure liquid level has a suppressed 0. This means the options are: the transmitter uses filter circuits to suppress the noise to a 0 level. The liquid is less dense than water. The transmitter is locked below the 0% of the liquid level mark. The elevation of the vessel is below sea level. So answer is 3. And next one here. The ratio control is where one variable is controlled in the proportion to another. A wild flow variable sets the gain of the controller. Fuel must be precisely rationed for economy. The rate of one of variable must remain fixed over time here. Okay. So the answer for this question is one variable is controlled in proportion to another, right? Next one. Unilateral Laplace transformation is applied to signal x of t. Okay. And x of t is a period, x of t is a casual, x of t is a non-negative. Both 1 and 3 are correct. So answer is x of t is casual. Next one. A closed loop control system with a positive feedback gain, the overall gain of the system will. Okay, the overall system of the gain will. So overall gain of the system will increase here. How it is, sir? So generally in case of negative feedback, we have seen the formula. AF is equal to A divided by 1 plus A beta. So here a positive sign, it indicates that the A plus beta factor is more, so that AF will reduce. The same case for the negative feedback, this is the formula. And if I take the positive feedback formula, so A divided by 1 minus A into beta. So this fraction will decrease, automatically the gain will increase. Okay, so that is the only advantage that available in the closed loop system. And we are using the positive feedback. So positive feedback in oscillators. Okay, in positive feedback in oscillators here. So let's move to the next question here. Next question is, phase margin of a system is used to specify which of the following. So phase margin is going to specify the relative stability of the system here. Okay, next question is, in PI controller, what does an integral function compute? So in a proportional integral control, what does an integral function compute? So it is going to compute the area under the curve here. So integral control is going to compute the area under the curve here. Okay, so let's take the next question here. So here this question is a problematic question. So we'll give the detailed explanation of this question here. Given a matrix A is 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6, the eigenvalues are. So for this question, you need to calculate the eigenvalues of this equation here. So let's take a fresh page and do the calculation here. So here the given question is right. So given matrix is given. So what we need to find is eigenvalues. The basic formula that the for the eigenvalues is it is a minus lambda I. Okay, so let me take here a minus lambda I you need to calculate here. Okay, so from that we are going to, if you make it 0, then you are going to find the value of lambda here. So first of all, what is a is nothing but is a matrix. Lambda value, lambda into I means, so I is nothing but entity matrix. So lambda I is nothing but, so lambda into I means 1 0 0 0 1 0 0 0 1 here. Okay, so from this what you can get simply, this is lambda I is nothing but, so this is lambda into I. Let me erase here, I'll write here again. So lambda into I is equal to, so lambda is equal to what? So lambda 0 0 0 lambda 0 0 0 lambda here. So this is the value. Now we need to differentiate, uh, lambda a minus lambda we need to make, right? So from that what you can do is, a minus lambda I is equal to, so take the entire matrix or 0, let me erase here, 0 1 0 0 0 1 minus 6 minus 11 minus 6 here. Okay, and subtract this matrix here, that is lambda 0 0 0 lambda 0 0 0 lambda here. Okay, now what we do is we will do the simplification here. So we need to make it lambda is equal to 0, we need to do, right? From this what you can do is, from we'll get the equation as, sorry, this matrix as 0 minus lambda means we'll get minus lambda here. So 1 minus 0 means 1, 0 minus 0 means 0, 0 minus 0 means 0, 0 minus lambda means minus lambda here, and 1 minus 0 is 1, and here we'll get minus 6 minus 0, okay, minus 11 minus 0 minus 6 minus lambda here. Okay, so we need to find the det for this matrix here. Okay, so how we are going to do this? So if you're going to det matrix, so det of this one, so det of a minus lambda into I is equal to 0. So for this we need to make the det here, that is first minus lambda into, I will cross multiply these two, minus lambda into minus 6 minus lambda. Okay, so this is a complete minus of minus means here plus lambda here, so this complete one part, and here minus 1 of, so minus 1 of 0 into this value means 0. Okay, we'll get plus simply 6 here. Okay, and plus 0 is equal to 0 here. So once we solve this equation here, we'll find the equation as 6 lambda square plus lambda cube plus 11 lambda value plus 6 value is equal to 0. So again I will rewrite this equation as lambda cube plus 6 lambda square plus 11 lambda value plus 6 is equal to 0. Okay, now substitute any value here. So substitute the values and check the answer. So which is going to suitable for this answer here. So I will substitute the answer this one. Okay, so I will check any one value. So I'll take one value, minus 1 here. So minus 1 whole cube me plus, okay, 6 into minus 1 whole square plus 11 into minus 1 plus 6 is equal to 0. So check any one value, it's sufficient. So minus 1 plus 6 minus 11 plus 6. Okay, so plus 6 plus 6 12 minus 12. So simply it's going to be 0. So answer will be what? This is the answer. Likewise, you can check any other value and substitute here. You can get the answer as this answer, right? So we'll move to the next question here. So let's go for the next question here. That is the 116. A system is described by the following state space model. X bar is equal to minus 1 0 1 minus 2 x plus 1 of 0 r of t, and the y is equal to 1 1 x. So from this we need to find the transfer function. So transfer function, the basic formula is transfer function is equal to, it is the c into si minus a whole inverse into b plus d. So in the given option, the matrix D is going to be 0 here. So this is the A matrix and this will be B, and here it will be C matrix. So we need to do the just matrix multiplication here. That's it. So nothing more is required here. Okay. So from this we can start our explanation here. So first of all, we'll take Si minus A inverse. So Sy means we know that Si minus A will take first of all. Okay. So Si minus A means S value means S0 0 S, that is multiplied S with the identity matrix minus of, okay, let me erase this part first of all. Okay, Si minus A value. So A value is equal to minus 1 0 1 minus 2. Okay, so after doing this you'll get S plus 1. Okay, and 0 minus 0 means 0, so we'll get minus 1, and here it is S plus 2. So this is the matrix that you got. Okay, S plus 1 0 S plus 2. Now Si minus A whole inverse means what you can get is det of this matrix, right? 1 by S plus 1 into S plus 2, that is a det. Okay, and matrix is going to be, it's going to be reverse, right? What is that? S plus 1, so here plus 1. Okay, so let me correct here, it is not, so D minus B here, D means S plus 2. Okay, so let's say A, B, C and D minus B means minus 0. Okay, so minus C means plus 1 here, and A will be 1 here. So this is the actual matrix here. So from this what I can get is if we resize it again, if we enter this here, you will get S plus 2 gets cancelled, 1 by S plus 1 here it will be 0, here 1 by S plus 1 into S plus 2, so this will be the, and here you will get it 1 by S plus 2, so this will be the Si minus A inverse here. Now we'll multiply with this with B. Okay, so first I will do the C into Si inverse. Okay, so C means, C matrix is what? So C matrix is nothing but 1 comma 1. Okay, now C into Si minus A inverse is equal to, what you can get is 1 1, we have 1 cross 2, and here we have 1 by S plus 1 0, 1 by S plus 1 into S plus 2, and here 1 by, okay, let me correct here, the pen is not writing properly, 1 by S plus 2 here like this. So this will be what? 2 cross 2 matrix. So now resultant will be what? It is 1 cross 2 matrix. Okay, so once you do this so you'll get it as, so let me take this entire part as a X here. Okay, so 1 by S plus 1, okay, into 1 by X. So here 1 by S plus 1 plus 1 by X I will take as, okay, or I can take simply X value, no issue at all. Okay, so simply I'll write X value, no issue at all. So here X, what is the value of X? X is nothing but 1 by S plus 1 into S plus 2. Okay, plus, so this will be 0, and 0 into 1 plus 1 by S plus 2. So this is the final we got here, right? Now what we will do is, we will take C into Si minus A inverse into B. So from this what you can get here it is, so from this what you can get is, so here, so 1 by S plus 1 plus X, 1 by S plus 2, okay, so into the B value. So what is the B value? So B is nothing but 1 0 here. So from this simply we can write this, the transfer function will be, okay, cross multiplication 1 by S plus 1 plus X into 1, okay, so plus 1 by S plus 2 into 0. So transfer function will be 1 by S plus 1 plus 1 by, okay, s plus 1 into s plus 2 here. Okay, now from this simplification, what you can get here, it is, okay, so s plus 1 into s plus 2 plus s plus 1 divided by, okay, divided by s plus 1 into s plus 1, let me erase here, s plus 1 into s plus 2 here. Okay, so one thing is, well, we can make a common s plus 1 here. S plus 1, if you make a common, s plus 2 plus 1 divided by s plus 1 into s plus 1 into s plus 2. So s plus 1 gets cancelled, means answer will be what? S plus 3 divided by s plus 1 into s plus 2, right? So the answer will be what? Here it is s plus 3 divided by s plus 1 into s plus 2. So I'll repeat the question here. Why? Because I made some confusion to you, right? So first thing is, we need to find the transfer function. The transfer function is c into si minus a inverse of into b plus d here. So in the given question, d value is 0, so we have taken that. First, what it is, si minus a, I have taken the value, and okay, after that I have taken si minus a inverse. So from that I got the equation here like this. Next, I have taken a c value, okay, c into si minus a inverse, I did multiplication here. So here the plus symbol should be there, okay, addition. So 1 into s plus 1 by s plus 1 plus 1 plus this value, right, x here taken. So after that I just did the matrix multiplication. So from that I did simplification, I got the answer as s plus 3 divided by s plus 1 into s plus 2. This is the right answer. So let's discuss next question here. A unity feedback control system has a open loop transfer function g of s is equal to 16 divided by s into s plus 4. The resonant frequency we need to calculate here. The basic formula for the resonant frequency is, that is, wr is equal to Wn natural frequency of oscillations into square root of 1 minus 2 zeta square. Okay, so from this transfer function, it's a open loop transfer function, we will make it as a closed loop transfer function. From that we will calculate the zeta value. So closed loop transfer function we will calculate. So closed loop transfer function is nothing but open loop transfer function divided by 1 plus open loop transfer function. So substitute this open loop transfer function, it's nothing but OLTF, right? So 16 divided by s into s plus 4 divided by 1 plus 16 divided by s into s plus 4. So once you simplify this equation, what you can get it here, it is, so 16 divided by s square plus 4s plus 16. Okay, so compare this with the standard equation, that is omega n square divided by s square plus 2 zeta omega into s plus omega n square. So from this comparison, so by comparison, what you can get, by comparison, so omega n square is nothing but 16. So from this, omega n equal to 4. Okay, we got omega n value here, and I want zeta value. So 2 zeta omega n is equal to 4. Okay, omega value, you know, omega n value is 4. So 2 zeta is equal to 1. That implies zeta is equal to 1 by 2. Okay, it's a value. Now final value, omega r is equal to, omega n is nothing but 4 square root of 1 minus 2 into zeta square. So zeta square is what? So zeta square means it is 1 by 2 whole square, right? Let me take here. So 1 by 2 whole square here. So what you'll get is 4 into square root of 1 minus again 1 by 2 here. So 2 gets cancelled here. So 4 into square root of 0.5. So answer will be 2.828. So answer will be what here? So answer is 2.828, and the units are radians per second here. So next question also here, that is from the control systems. Now here, a forward path gain of a unity feedback control system is the given g of s is equal to 144 divided by s into s plus 12, the peak time of the system. So we need to find the peak time. So how can you find the peak time here? So peak time Tp is equal to, so pi by omega d. The formula is Tp, peak time, is equal to pi divided by omega d. What is omega d value? So omega d, damper frequency of oscillation, is equal to natural frequency of oscillation into 1 minus zeta square. Now here we need to find the value of zeta as in the previous case. So first what we'll do is, we'll closed loop transfer function, you'll write. So once you write the closed loop transfer function, we'll get 144 divided by s square plus 2, no, it's not 2, right? It is here, s square plus 12s plus 144. Compare the standard equation omega n square divided by s square plus 2 zeta omega n s plus omega n square. So omega n is nothing but here, omega n is nothing but 12. Okay, 12 square means 144, and 2 zeta omega n is nothing but 12 here. So similarly, you get zeta is equal to 0.5. Okay, we got it. Now omega d we want. So omega d is nothing but natural frequency of oscillation is 12 into square root of 1 minus zeta square means 1 by 4 here. So simplify this, we will get it as 6 into root 3, got it, right? Now Tp, the peak time is equal to, so pi means 3.14 divided by 6 root 3. So this value is going to be 0.3021. So answer will be, here it is a 2. So that's the answer for this question here. Okay, so units will be seconds here. So let's move to the last question of this paper. So this is the last question of this paper here. That is, the transfer function of first order system is given by g of s is equal to 8 by s plus 4. The final steady state value of the unit step response. So this is the question that asked in the previous papers of Tneb. So same pattern here, right? We want the final steady state value or DC value. Okay, so we'll find the limit s tends to 0, the s into g of s. Okay, s into g of s. But what is the input here? It is a step response, so it's going to be 1 by s. Okay, limit s tends to 0, s gets cancelled here, so g of s is nothing but 8 by s plus 4. Substitute the value of s is equal to 0, 8 by 4 is nothing but 2 here. Answer will be 2. Okay, so that's it for this session. Thank you friends, thanks for watching my video. So if you are new to the channel, please subscribe to my channel and share with your friends. Okay, have a nice day. In the next upcoming videos, we will discuss the JEDCO 2017 electrical paper. Okay, have a nice day.